be chain rule. So with AP, we're going to treat it like an AP test. So anytime it's free response, we'll leave the answers the way they are. Anytime it's multiple choice, we're going to have to simplify to try to match the answer. So we just want to take a derivative of these guys. So the first one, just to start out chain rule, bring 3 down, subtract 1 off. So y prime is going to equal 3, 2, and then leave the inside alone. Times it by the derivative of the inside, so times it by 2. So that's my answer. Again, if you want to simplify, in this case, you don't really have to. You could get this. The next one, you're like, that doesn't look like a chain rule. That looks like a quotient rule. It is a quotient rule if you want to do it that way. But if you want to make it a chain rule, you can also, there's like a little neat trick. You can do that and flip it up. So it actually looks like this. And now it's a chain rule. So again, you could have done a quotient rule, you get the right answer. But a little trick here, you can flip it up and then make it a chain rule. So now we're just going to bring that down, subtract 1 off. So I get y prime equals -1 t squared plus 3t minus 1 to the -2 times by the derivative of the inside, which in this case would be 2t plus 3. And again, if it was multiple choice, I have to flip this down, put that on top. But I'm going to treat it like a free response question, so I'm going to leave it like that, and my answer is done. This next one, you're not going, oh, that looks like a quotient rule inside a chain rule. But really, if you simplify this, and you get 1 squared, which is just 1, over t minus 3, and then we use the exact same trick and move that up. And now it's just a basic -2. And now it's just a basic chain rule. Bring 2 down, subtract 1 off. So -2 down, sorry, t minus 3. So -3 times by the derivative of the inside, which is just 1. So there we go. Next one, cosecant cubed 3x squared. So remember, I'm going to rewrite this to make it y equals cosecant 3x over 2 cubed. So now I got to take the derivative of this. So it's like a double chain rule. So bring the 3 down, leave the inside like that, leave the inside alone. Now we're going to times it by the derivative of the inside. Now the inside, the thing I left alone was this guy. That in itself is a chain rule. So derivative of cosecant, negative cosecant cotangent. Remember, derivative secant is secant tangent. Derivative cosecant, co is negative. So negative cosecant cotangent with the 3x squared left inside. So that's always a little tricky one for people. When you take a derivative of this, and it's a chain rule, this goes inside of both of them. So it's not, people think cosecant, and they go, okay, cosecant x, cotangent x. But if there's something inside of that, that something inside has to go to both of them. So it's going to look like this. Cosecant, negative cosecant, sorry, 3x over 2, cotangent, 3x over 2. That's how it works. So when you do a chain rule with something inside like that, it goes to both of them. And then, actually I'm not done yet, right? I left something alone. I left these guys alone. So times by derivative of one of them, 3 over 2. Because that's the inside, just happen to go to both. So this is my answer. And again, it's free response, so we're just going to leave it like that. Thank goodness. Next one, kind of same idea, now it's secant. So I'm going to rewrite it first. Like that. Change the color so it's a little easier to see. I'm going to take a derivative, it's another double chain rule. So we're going to bring the 3 down. So I get 9 squared, leave the inside alone. Secant pi t minus 1. Now times by derivative of the inside. Derivative of the inside is secant. So derivative of that would be secant tangent. So times secant, leave the inside alone. Pi t minus 1 times tangent, leave the inside alone. Times by derivative of the inside of that, and the derivative of this guy right here is just pi. And that is my answer. Again, we're going to leave it like that. Next one, f here, sine of cube root of x, and then cube root of sine of x. So let me rewrite these so you can see them. So this is sine of x to the 1/3, right, only for the x. And this one is sine inside the 1/3 power. So we're going to teach each one separately. So this one's like a little chain rule. So the outside sine. So take derivative of the outside, cosine, leave the inside alone. Times by derivative of the inside. Derivative of x cubed is 1/3 x to the -2/3. Then plus derivative of this one. So in this one, kind of same idea, but the outside is actually the 1/3. So bring it down, subtract 1 off, I'm going to get 1/3, leave the inside alone. times by derivative of the inside. Derivative of sine is cosine. X. Kind of hard to see. I feel like I gotta move this. Let me move this over here. I'm running out of space. There we go. I got some skills, and that goes there. 1/3 sine of 2/3 times cosine of x. So that's our answer for that one. Let's go here. I'll erase it. Don't need this anymore. Okay, so this one, take a derivative here. Now this is, notice the two separate x's that give away to product rule. So this is one of my functions, that's the other function. So product rule, remember f times g is the derivative of the first one times the second plus the derivative of the second times the first. So derivative of f of x squared is 2x, leave the tan of 1 over x alone, plus the derivative of tan 1 over x. So to do that one, I got to rewrite it. So it's tan x to the -1. And that's a chain rule, right? So derivative of tan is secant squared. So secant squared, leave the inside alone. Times derivative of the inside, derivative of x to the -1 is bring it down. Subtract 1 off. Times, don't forget, times the first one left alone. You get all that. All right, again, we're doing free response. We're going to leave it like that. We're good. Next one. Sorry about the, there's not that much space. These are funky. It's an AP one. They're always going to be kind of funky. The next one. Notice the two separate thetas here. So it's another product rule. And each one has their own little chain rule attached to it. So let's say this is my f, that's my g. I like it a little better when I can separate. So there's one and there's the other one. There we go. So the derivative of the first one, derivative of secant is secant tangent. So we're going to get secant 2 theta tangent 2 theta. Right, that's the derivative of the first one. Gotta leave the second one alone. So times tan 2 theta plus derivative of the second one, derivative of tangent, it's just secant squared. So secant squared 2 theta. And actually I'm wrong. I messed up already. I forgot that right here, these are chain rules, right? So I took derivative of them, but I forgot times it by derivative of the inside, times it by 2. So right, secant 2 theta times tan 2 theta, leave the inside alone, times by derivative of the inside, which is 2. Totally forgot about that part. Tan 2 theta is fine. Over here, secant 2 theta times derivative of the inside. That's why it popped in my head. Times 2 times the second one left alone. So secant 2 theta left alone. And that is the answer. That mess right there. The next one. So you want to rewrite it, but before you do it, look at it. What do you notice? There's no variable. There's no x. My variable here is x. There's no x. What's the derivative of something without a variable? 0. It's a constant. There's that. Next one. So we have h of x equals tan 2x. We evaluate the second derivative at this point here. Simplify early and often. So let's take our first derivative first. First derivative is just a chain rule. Derivative of tan is secant squared 2x times the derivative of the inside 2. So I get 2 secant squared 2x. That's the derivative of the first one. So that's our first derivative. Take a derivative again. Now that's not too bad. It's not going to be a product rule or anything, so it's another chain rule. So the second derivative is going to be take derivative of the outside. Derivative secant squared, that is a chain rule though. Let me rewrite this so it's a little easier to say. Secant 2x squared. That is a chain rule. So bring the 2 down. So 4. Leave the inside alone. Right, so the first power times by derivative of the inside. Now this is my inside. Derivative of secant is secant tangent. So it's going to be secant 2x. I want to leave the inside alone. Tangent 2x. Leave the inside alone. Times by the derivative of the thing left alone, which in this case was 2x. So the derivative of that is just 2. So that's my function. Now we're gonna simplify at pi over 3. Like the rat 3 doesn't mean anything. It's just your y value. It's all about the x of pi over 6. We're gonna plug pi over 6 into all this. So we're gonna plug in pi over 6, pi over 6, pi over 6. Let's simplify this a little bit. So 2 times 4 is 8. I got secant. Now pi over 6 times 2 is pi over 3. Then secant pi over 3, then tangent pi over 3. Well, let's figure out what these things are at pi over 3. Quadrant 1, 3 is 60 degree angle. Pi over 3 is 60. It's like 180 divided by 3. So that makes this rad 3, 1 and 2. Secant is opposite of cosine. So cosine would be 1 over 2. So secant would just be 2. And tangent's TOA. So opposite over adjacent. So rad 3. So I get 8 times 2 times 2. 8 times 4 is 32. 32 times rad 3. So 32 rad 3. That's my answer. Okay, the next one. Given g of 5 equals negative 3, g prime of 5 equals 6, h of 5 equals 3, h prime of 5 equals negative 2, find f of 5, if possible. So the first one here, just a quotient rule. So just going to do the quotient rule. So again, we're going to do all this at 5. I want to find f prime of 5. So first quotient rule though. Derivative of the top, g of x, times the bottom, h of x, minus derivative of the bottom, h prime of x, times the derivative of the top, all over the bottom squared. Now all this is going to be at 5, so I'm going to plug 5 into everyone. So g prime of 5 is 6. H of 5 is 3 minus multiplication. H prime of 5 is negative 2 times g of 5, negative 3, all over h of 5 squared. H of 5 is 3, so 3 squared. So I get 18 minus 6 over 9. So I get 12 over 9. Again, don't need to simplify if you do. 4 over 3, but you don't need to. The next one, so this is a chain rule, right? So take derivative of the outside. So that's going to be g prime, leave the inside alone, times the derivative of the inside, h prime of x. Now all this is going to be at 5 again. So let me plug in 5. This time I'll actually show it because I think it does matter a little bit more here. So that's not going to do without showing it. So h of 5 we talked about, h prime of 5 we talked about, it's negative 2. H of 5 is 3. And now we have g prime with 3, which I don't think they give us. Right, there's no g prime with 3, so this is not possible. Because it's not given. Okay, the next one, that's a product rule. So we're going to take derivatives, notice the 2 separate x's. Compared to this one, there's only one x. So product rule, take the derivative of the first one, times the second, plus the derivative of the second one, times the first. Again, this is all at 5, so we could just plug in, pretend we're plugging in 5 for all these. So g prime of 5 is 6. H of 5 is 3. H prime of 5 is negative 2. And then g of 5 is negative 3. So I get 18 plus 6, so 24. Okay, moving on. It's another chain rule. Bring 3 down, subtract 1 off. So I get 3 squared, and then leave the inside alone. Gx times the derivative of the inside. G prime of x. Again, I'm plugging 5 into all these, so I need g prime of 5 and g of 5. G prime of 5 is 6, and g of 5 is negative 3. So this is 6, and this is negative 3. That gets me 9 times 6. So 18 times 6, which is 162. Next one. That was a little messy, sorry about that. That's a 6. Okay, looks a little bit prettier. Next one, it's another chain rule. So g of all this. So anytime I say like of, chain rule. So g of x plus h of x, that's a chain rule. So I get rid of the outside, g. Leave the inside alone. Oh, sorry, g prime. Then leave the inside alone. So the derivative of g is g prime plus h of x, like that. Times the derivative of the inside. Derivative of the inside is 1 plus h prime. Again, if I'm plugging in 5 for everything, right? So if I plug in 5, 5, and 5, I'm going to get g prime of 5 plus h of 5 times 1 plus h prime of 5. What's h prime of 5 and h of 5 are things I need right now? Negative 2 h prime and 3 h of 5. Negative 2, I forgot it. Negative 2, 3, okay. So if I simplify this, I get g prime of 8 times negative 1. And we don't have g prime of 8, so I can't do it. Not possible. That wasn't given to us. Okay, this one. Another chain rule. Negative 2's, it's g of x plus h of x, also negative 2 powers. That's a chain rule. Bring the 2 down. So I'm going to get -2, subtract 1 off, -3, leave the inside alone, g plus h, times the derivative of the inside, which is just g prime plus h prime. It's a little messy. Let me draw it again. So I'm going to get -2, g of 5, h of 5, also -3 power, times g of 5, g prime of 5, and h plus h prime of 5. A little better, not much. Okay, so g prime, I need all these. So g of 5 is -3, g prime is 6. Is that -3? Yeah. So -3, and that's 6. Oh, this is not the best. H of 5 and h of -5. H of 5 is 3 and -2. So this is 3 and this is -2. So now I can write it a little bit nicer. -2, -3 plus 3 to the -3 times 6 plus -2. So I get -2, 0 to -3 times 4. There's a problem here. If I flip that, right, that's all negative does, is flip it, times 4. You can't divide by 0, so this is undefined. So it is possible, it's just undefined, like no solution to that one. Okay, let's move on. Now we have some multiple choice. No, so again, I took these straight from like AP exams. So you'll see this, you might see like 1 or 2 of these on the AP exam. So you gotta simplify this, and then you gotta match the answer. So we're gonna take a derivative of this guy, and then find the answer. So derivative of this, let's rewrite it. So I can't take a derivative the way it is. This is x squared plus 3 to the -1/2 power. Right? If I took a step back, that'd be 1 over x squared plus 3 to the 1/2. But then you gotta flip it to the top because you only need to take a derivative that's been on top. So x squared plus 3 to the -1/2. Now that's a chain rule when we actually start taking the derivative. So y prime, or I guess in this case f prime, doesn't really matter. Bring it down, subtract 1 off, common denominator. So I get -1/2, -3/2. Leave the inside alone, and then times it by derivative of the inside, which would be 2x. Alright, so I get that. Now I gotta make it match. So notice how this does not look like this, any of those, right? So I gotta work with it a little bit. So I can multiply this and this. These will cancel out, and I get -x. I could flip that to the bottom because it's a negative power, so I get x squared plus 3 to the 3/2. Now it looks closer to this, and here you probably could just parse it out and be like, okay, I know what this is. I know what this looks like. This is a square root of the third power. It looks like this guy, but I need the -x on top, so it's be over here. So you don't have to go all the way down to it matches. You don't get credit for showing your work. So once you get to the part where like, okay, I think I can match it, then you stop there and match it. If not, go a little further. Right? This is square roots on the bottom. So I get x squared plus 3 cubed. So there we go. Next one. This is a classic one. So if g of x equals 1 minus x cubed times 4x plus 1, find g prime. And then you got to match it. Now I said it's a classic one because notice here, there's 2 x's. So it's a product rule, but one of them is a chain rule. So there's first going to be a product rule, f times g. If you remember product rule, it's f prime times g plus g prime times f. Right? And then we also got to simplify it. So it's a classic AP problem. So let's do f prime first, right? So derivative of this, that's a chain rule. So bring the 3 down, subtract 1 off. So it's going to be 3, 1 minus x squared times the derivative of the inside, which in this case is just -1. So keep in mind that that's only the derivative of the first one here, right? It's only f prime. To chain rule, bring 3, subtract 1 off, you get the 2, leave the inside alone, times by derivative of the inside. We still got to multiply by the second one left alone. So times by parentheses 4x plus 1 plus derivative of the second one, derivative of this guy is easy, that's just 4 times f left alone. So 1 minus x cubed. Sorry, 1 minus x cubed on the outside. Very important. I don't mess that up. Now, so you should know right away, like, oh, I don't see my answer here anyway, right? If it's free response, I am done. I can walk away from this problem. But multiple choice, I gotta make it look like one of these. So, let's factor. Pull out what they have in common. Now, if you look at this, you always want to pull, like I said before, you always want to pull out the one with the biggest thing. These guys, it's the first thing you should look at. So you pull out whatever they have in common. So 2, I can't pull out 3, this doesn't have it. So x squared is the most I can pull out. It's 1 minus x, whole thing squared. That's gone, this is down to 1. Anything else? There's a 4 here, but that's connected. I can't pull that out. So that's pretty much it. Everything else is the left hand side. Okay, so what's left inside here? I got 3 times -1, so -3. I have 4x plus 1. Then over here, I have the 4 and then the 1 minus x. There's only one of those left. Now sometimes you might want to see if you could take out some of these answers here. But in this case, so far they all match, right? Maybe not this one, but we'll see how it turns out. Right, so they all have the 1 minus x squared. So I just got to simplify this correct, and it should be home free. So I get -12x minus 3 plus 4 minus 4x. Add like terms. So I get what looks like -16x plus 1. And then I have a 1 minus x squared on the outside. 1 minus x whole thing squared, sorry. And close right here. I mean, it's not the exact same thing, but if you rewrite it, the exact same thing, right? So if I rewrite that, it should be this. So there you go, it's C. Next one, it doesn't get any prettier. Okay, so this is another chain rule. I don't think there's any easy way around this one. It's just going to be a chain rule with the derivative of the inside happening to be a quotient rule. Oh, that's disgusting. Okay, so let's do the chain rule. Take the derivative of the outside, 5. Leave the inside alone. That's going to be to the 4th power. So like that. Now I got times by the derivative of the inside, which happens to be a big old quotient rule. So the derivative of the top, 2x, times the bottom left alone, 5x squared minus 9, minus derivative of the bottom. Derivative of the bottom is 10x. Right, bring the 5 down, subtract 1, take x goes away, times the top left alone, x squared minus 3, all over the bottom squared, 5x squared minus 9 squared. So you have all of this. Okay, now basically this time mess this up, so simplify. Remember, bring out the -10, got to simplify to both of these, so I'm going to get 5. Now look at here, how all your answers have them kind of separated, they're not like together like this. I'm going to separate this. 5x squared minus 3 to the 4th over 5x squared minus 9 to the 4th. Right, you see the number in front here? That's always over 1, right? If you don't see a fraction, every number is a fraction. If you don't see it, it's just over 1. So that's why I wrote it like this. And then over here, what do we have? We have 10x cubed minus 18x. And again, you always bring the sign with this guy. So -10x times x squared is -10x cubed. And then -10x times -3 is a positive 30x. So let's write it here so I can work with it. Plus 30x. And at the bottom, I'm just going to leave it the way it is. Okay, then let's see what happens. Now it looks like my 10x's cancel out. How nice. And it looks like I add the powers here. Okay, -18x and 3x, that gets me 12x. So I'm going to have 12x on top. I have 5x squared minus 9 squared on the bottom times 5x squared minus 3 to the 4th over 5x squared minus 9 to the 4th. That's pretty much all I could do. Now it doesn't match right away, so I probably simplify a little bit more. I can multiply the 12x and the 5 to get 60x. X squared minus 3 to the 4th. And then the bottom I can combine these, so they're both the same, so you just add the powers. 5x squared minus 9 to the 6th. And does that match anywhere? Right here. D. It's the only one that matches, so there we go. Okay, next one. So our last one here. A derivative function f is attained by using the chain rule. The result is f prime of 3 secant x tan x. Which of the following could be f of x? 1, 2, or 3. So we're saying, basically what we got to do is take a derivative of each one of these and see which of them gets me that as an answer. Again, these are all taken from old AP exams, so get used to it. So let's take a derivative of this one. Derivative of negative pi is 0. Derivative of secant to the 4th. So that's all I have to matter. So let me rewrite it, because that's what matters. So like this. Right, so I take a derivative of this guy. This goes away. Bring this down, subtract this off. So I get 4 times 3/4 cancels out. You just get 3. That's a 3 now. We have a secant on the inside, and then derivative secant is secant tangent. So this gets me 3 secant to the 4th times tan of x. So that one doesn't match. So it's not 1. It has 1 too many secants. And then, so we got 2 more left to try. Let's try this one. So I'm going to rewrite it first again. So 8 plus secant x to the 3rd. Right, derivative of 8 goes away. Secant, so chain rule, bring that down, subtract 1 off. So 3 secant x squared times the derivative of the inside. Derivative of secant is secant tangent. If I simplify it a little bit, combine these. Secant cubed x tan x. Which does match. That's exactly what they wanted. So 2 is good. Now he's got to decide is 3 good or not. It's 3 okay. Let me rewrite. I've been rewriting it, so let me rewrite it first. So secant x plus secant x tan x squared. Now this one's more of a pain in the butt. So right here is fine. Derivative of secant is secant tangent. No problem. All good. Here's where it's a little bit of a problem. We got a product rule, just 2 separate x's, but inside that product rule, I have a chain rule right here. So it's kind of both, right? So it's a product rule and a chain rule. So product rule comes first because it's on the outside, right? And then inside the product rule, you happen to have a chain rule. It's kind of what you want to think about it. So it's product rule. Inside that product rule, there happens to be a chain rule. So derivative of the first one's secant, so that we know it's secant tangent. Whoops. So this guy's going to give me secant x tan x. Let me do this guy in a different color to separate this guy being green. So that's the derivative secant. And then derivative tan, oh, then this one I leave alone, so it's all of that. So it's tan x squared. That's all the g. And then we're going to go plus, right? Now we're going to flip it. Derivative of this guy. That's a chain rule. Derivative 10 squared, we're going to bring the 2 down, subtract 1 off. So I get 2. Leave the tan alone. Times the derivative of the inside. Derivative of 10 is secant squared. And then we got times by the first one left alone. So I'm going to go back to the red. So I get times secant x. So I get all of that, right? So again, this was just this guy. Secant, this was a product rule with the chain rule inside of it. So derivative of the first one gets me this. Times the second one left alone is that. Plus the derivative of the second one, that's a chain rule. Got me all this. And the first one left alone. Now you're going to combine things. So let's see, I get secant tan plus, or there's 3 tans here, so secant tan cubed plus, over here there's 3 secants, so 2 tan of secant cubed. Now we go into our math vault. So right now it looks like, I would say no, it doesn't look like the thing we're supposed to look like. It doesn't look like this guy. But there's still more math we could do. Like, notice they all have a secant tangent. Let's pull that out. So secant tan on the outside. That'll leave a 1 plus tan squared plus 2. One of the 10 is secant out. So 2. That's gone. One of those is gone. It's like that's gone and one of those is gone. And that's gone. That's gone. So 1 left. So 2 secant squared x. And you're like, okay, well, there's a trig identity. Tan squared equals 1 secant squared minus 1. Good old trig. So I get 1 secant squared minus 1 plus secant squared minus 1 plus 2 secant x squared. Now look at it. The 1's cancel. These cancel out. I'm left with secant x tan x secant squared x plus 2 secant squared x. I could add those up and I get secant x tan x times 3 secant squared x. Multiply the tan and secant together, you get 3 secant cubed x tan x, which I think is what they want us to get. Yeah, so that works too. So it's 2 and 3. And that's the worksheet.